Good day everyone. I am Rosa Angela B. Kibada, a BS IT student, Section B. So in this video, I am going to demonstrate on how to convert decimal, binary, octal, hexadecimal, and vice versa. So let me first demonstrate on how to convert decimal to binary. For example, we are going to convert the number 89 into a binary. In order to convert that number, we should first familiarize the powers of 2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. 2 to the sixth power is 64. And so on. After that, we are going to locate the number here that is less than 89. So it will be 64. Then we will subtract the number 89 and 64, which will result to 25. Then again, we will locate the highest number here that is less than 25. So it will be 16. Then again, we will subtract 25 and 16, which will give us the number 9. And again, we will find a number here that is less than 9, which is 8. Then subtract highest number of 1 is 1, so I'll put it here. If we add this number, it'll result to 89. After getting this, we can now turn this into a binary number. So the 64, 16, 8, and 1 will turn into number 1, will become a number 1. And those numbers that aren't here will become 0. So the binary number of 89 is 1011001. So that's it. That is the process on how to convert decimal to binary. The second process that I will demonstrate is on how to convert binary numbers to octal numbers. So for example, we will again use the binary numbers of 89, which is the 1011001. So to convert these binary numbers into octal numbers, we should first separate this into group of 3. So it'll be 001, 019. And because we don't have enough numbers to make another group of 3, we're going to add 2 zeros, so it'll be 001, 011, and 001. Then we will use the powers of 2. So it'll be 1, 2, 4, 1, 2, 4, 1, 2, 4. Then we will multiply. 4 times 0 is 0. 2 times 0 is 0. 2 times 1 is 1. 4 times 0 is 0. 2 times 1 is 2. 1 times 1 is 1. 0, 0, 1. Then we will add these numbers. So it'll be 1. 2 plus 1 is 3. And 1. So the octal numbers of these binary numbers are 131. So that's it. That's how you convert binary numbers to octal numbers. And lastly, I will demonstrate on how to convert decimal to hexadecimal. So again, we will use the number 89. But before that, we must know the numbers that corresponds from decimal to hexadecimal. So from numbers 0 to 9, decimal and hexadecimal corresponds the same. Because 0 corresponds to 0 in hexadecimal, 1 is 1, 2 is 2, 3 corresponds to 3, 4 corresponds to 4, 5 corresponds to 5, 6 corresponds to 6, 7, 7, 8 corresponds to 8, and 9 corresponds to 9. Then it changes when the number is 10, because 10 in hexadecimal corresponds to A, 11 corresponds to B, 12 corresponds to C, 13 corresponds to D, 14 is E, and 15 is F. We must keep this in mind in order to convert decimal to hexadecimal numbers. So let's go back to converting the number 89. So since hexadecimal is 16, we will divide 89 by 16, which will result to 5.5625. We'll put this here, and then we will get the remainder. To get the remainder, we must multiply 0.5625 by 16, which will result to 9. Then we will now use this here, 5 divide 16, which will result to 0.3125. Just 0, then get the remainder here and here, multiply, which is 5. Then this is now considered the most significant number, and this is the least significant number. We will now convert this to hexadecimal, so 5 corresponds to 5 and 9 corresponds to 9. So we'll write it from most significant number to least significant number. So 89 is 5, 9, 16. So the hexadecimal number is 59. So the hexadecimal number of 89 is 59. That's it. That's how you convert decimal to hexadecimal.